So now we will learn about factoring. So there are several techniques when it comes to factoring, and we will start with factoring by grouping. We will start explaining these concepts through examples. So the first one we have is x cubed minus 2x squared plus 5x minus 10. So I will group this into two groups. First one being x cubed minus 2x squared, second one being 5x minus 10. I can notice x cubed is x squared times x, so I can factor out the x squared, which gives me x minus 2, and I can factor out the 5 in the second group, which also gives me 5 times x minus 2. Now I can notice that x minus 2 is a common factor, so I can factor it out, and I get the following answer. Next, I will show you how to factor with common factors. So I will start by maybe factoring out the first common factor that's maybe obvious to see, which is the y. So I get 12y squared minus 15y plus 6. And then I might notice that 12 is 3 times 4, 15 is 3 times 5, 6 is 3 times 2. So I might as well factor the 3. And this gives me 4y squared minus 5y plus 2. Now this is a quadratic. I will try to factor it and see what happens. I will use the quadratic formula. So let's find b squared minus 4ac. A is 4, b is negative 5, and c is 2. So b squared is negative 5 all squared, which is 25, minus 4 times 2, which becomes 25 minus 32, which is negative 7. This is less than 0, it's negative. I cannot take the square root, so my answer remains the following. Now we will look at factoring by substitution. So if I have this polynomial, I will set y equals to x cubed, and then I will rewrite the polynomial using y. So x power 6 is y squared minus 54y plus 15, and this looks much easier to simplify now. So I will first factor out the 27. I get y squared minus 2y plus 5 over 9. So y, this is 1y squared, so a is 1, b is negative 2, c is 5 over 9. Because of that, I can use the formula negative b plus minus square root of b squared minus 4ac over 2a, which gives me negative b is negative of negative 2, so 2 plus minus a square root of b squared, negative 2 all squared is 4, minus 4 times 1 times 5 over 9, divided by 2a, so 2 times 1, which is 2. This becomes 2 plus minus 4 over 3 over 2. I get two answers, the first one being 5 over 3, and the second one being 1 over 3. So now these are what we call the roots. And don't forget that when we have roots, I will write my answer down here. When we have roots, don't forget the negative sign. So it's y minus 5 over 3 and y minus 1 over 3. And now we will put the x back. So y is x cubed. And this is our answer. Now let's look at the factor theorem. So what does the factor theorem tell us? It tells us that if f of n is 0, then x minus n is a factor of x. Also, the other way around is true. So if x minus n is a factor of f of x, then f of n is 0. So in case you did not get this wording, an example might be if f of x is equal to x cubed plus 2x squared minus 7x plus 4. This is f of x. And if we know that f of 1 is 0, then f of x is equal to x minus 1 times something else. And we will look at an example in a few minutes to help us understand this. And before we go to the example, I just wanted to give you a few properties that you should know. So x plus y all squared is x squared plus 2xy plus y squared. X minus y all squared is x squared minus 2xy plus y squared. And you might be noticing the sign here. Now a squared minus b squared is a minus b times a plus b. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. It's really good to memorize these, and if you ever forget, let's say what x plus y all squared is, you can always do it the long way. This gives x squared plus xy plus xy plus y squared, which is x squared plus 2xy plus y squared, as we just showed. Now, as I promised, we will do an example with related to the factor theorem right now. So if we're told that f of x equals to x cubed minus 4x squared plus x plus 6, if this is f of x, and we are told that f of 3 is 0. So what can we do with this information? We would like to rewrite f of x in terms of, we would like to factor f of x. So what we will do, using the factor theorem, we can now say that this is equal to x minus 3 times something else. Now, what is this something else? So we can do long division and figure this out. So we will look at the first term. So x cubed, we have x cubed here. How can we get x cubed from this x? In here, we multiply it by x squared. X squared times x is x cubed. X squared times 3 is 3x squared. And now we subtract. X cubed minus x cubed is 0. Negative 4x squared minus negative 3x squared is as if we're saying negative 4x squared plus 3x squared, which is negative x squared. We drop the rest. So negative x squared plus x plus 6. Now, again, we look at the x and we look at the x squared. We multiply x by what to get negative x squared? We multiply it by negative x. Negative x times x is negative x squared. Negative x times negative 3 is positive 3x, and now we subtract. So negative x squared minus negative x squared is 0. X minus 3x is minus 2x, and we drop down the 6. So this is the last time. So negative 2, if we multiply it by x minus 3, we get negative 2x plus 6. We subtract, we get 0 because we're subtracting negative 2x plus 6 from itself. And this up here is the something else. So we will rewrite this as f of x equals to x minus 3 times x squared minus x minus 2. So for now, I will not use the full quadratic formula of b squared minus 4ac. I will do this the quick method. So if I have two numbers, I multiply them, I get negative 2, I add them, I get negative 1. What are these two numbers? So they are negative 2 and positive 1. As you can see, negative 2 times 1 is negative 2. Negative 2 times positive 1 is negative 1. So this is our answer. We have written f of x as x minus 3 times x minus 2 times x plus 1. Moving on, we will learn how to solve algebraic equations and inequalities. So maybe like a standard method to follow is to start by simplification, isolating the variable, factoring, and then solving for the variable. Now this method might differ from one problem to another, but we will see how we will use it. So first of all, let's start with example 1, which is we're given a polynomial. So we have 5x squared plus 7x minus 9 is equal to 4x squared plus x minus 18. So we will start by simplifying like terms. We can see that we have an x squared on both sides. We will put them on one side. 5x squared, when we take the 4x squared to the other side, it becomes minus 4x squared. So now we have 5x squared minus 4x squared gives us x squared. Now we have 7x and x on the other side. So 7x minus x becomes 6x. Also, negative 9 minus negative 18 is negative 9 plus 18, which is 9. So this is equal to 0. Now we have a quadratic. This might look familiar. We learned earlier x plus y all squared is x squared plus 2xy plus y squared. So this is x plus 3 all squared. And now, how do we solve for that? We square root both sides. We get x plus 3 equals to 0, so x equals to negative 3. Now, our second example, we are working with rational expressions. We have fractions all over. So, the first thing we might want to do is to put all the fractions on one side. So let's do that. We get x over x plus 2 minus 1 over x minus 2 minus 4 over x plus 2 equals to 0. Next, we want to simplify. So we need a common denominator. We can see here we have x plus 2, here we have x minus 2, and here we have x plus 2. So maybe a good common denominator could be the product. So x plus 2 times x minus 2. And so for the first fraction, I want a denominator of x plus 2 times x minus 2. Since I multiplied the denominator by x minus 2, I should also multiply the numerator by x minus 2. For the second fraction, same thing. I multiplied the denominator by x plus 2, so I should also multiply the numerator by x plus 2. Third fraction, I multiply the denominator by x minus 2, so I will also multiply the numerator by x minus 2. Since all of these have the same denominator, I can write them under one fraction. And this will give me x times x minus 2 minus x plus 2 minus 4 times x minus 2 equals to 0. And again, I will continue simplifying this. This will give us x squared minus 2x minus x minus 2 minus 4x plus 8 over x plus 2 times x minus 2 equals to 0. One thing worth noting that in a rational expression in a fraction, the denominator can never be 0. So if this expression is equal to 0, then the numerator is equal to 0. So x squared minus 2x minus x minus 2 minus 4x plus 8 is equal to 0. Now we can take like terms. This is a polynomial now. So x squared, we have minus 2x, minus x, and minus 4x. So this gives us minus 7x. And now we have 8 minus 2, which is plus 6 equals to 0. So what two numbers, if multiplied, give us 6, and if added up, give us negative 7? These numbers are negative 6 and negative 1. So now our answer is x equals to 6 and x equals to 1, or x equals to 1. So in this example, we saw that the first step, we put all fractions on one side. Second step, we simplified, and third step, we solved. Now our third example involves square roots. Square root of x squared plus 4 is equal to 3x. So the first thing we might do, put the square root on one side, isolate it. And it is already on one side, it is isolated, it is given this way. So this step is done. Our next step might be to square both sides. So let's square both sides. Squaring cancels out the square root. So on the left-hand side, we get x squared plus 4. On the right-hand side, we get 3 squared, which is 9 times x squared. Now, let's simplify. Simplification happens often with like terms, which we have here. So let's put them all on one side. 9x squared minus x squared is 8x squared. And let's move the 4 to the other side. 8x squared minus 4 equals to 0. Now, let's continue with the simplification. We have a common factor, which is the 4. So if we factor out the 4, we get 2x squared minus 1 is 0. Now, so this is multiplication. So if the answer is 0, at least one of these two factors has to be 0. We can clearly see that the 4 is not 0 because 4 simply is not 0. So 2x squared minus 1 has to be 0. And how can we simplify this? Maybe if I rewrite it in a different way, it might look clearer. So 2x squared is as if I'm saying square root of 2x all squared minus 1 squared is 0. And why did I do that? Because we saw earlier that a squared minus b squared is a minus b times a plus b. So now I can rewrite this because in our case, square root of 2x is a and b is 1. So I would like to rewrite this as a minus b times a plus b, which is 1, equals to 0. And now, if this expression equals to 0, then at least one of these two factors is 0. So square root of 2 times x minus 1 is 0, or square root of 2 times x plus 1 is 0. I will solve each one of them. On the left, we get x is equal to 1 divided by square root of 2, and on the right, we get negative 1 divided by square root of 2. Whenever you're working with functions that have square roots in them, it is very important to check your answer at the end. So we got two answers for x, the first one being x equals to 1 divided by square root of 2, and the second one being x equals to negative 1 divided by square root of 2. So we will plug these values of x into our left-hand side and our right-hand side in order to check whether they are correct or we have to reject. So let's start with 1 divided by square root of 2. We will start by plugging it in the left-hand side. So left-hand side equals to, we have square root of x squared plus 4. Instead of x squared, we put 1 divided by square root of 2 all squared plus 4. This becomes 1 squared over square root of 2 all squared plus 4, which is 1 over 2 plus 4. We can have a common denominator, which is 2. So this gives us a square root of 9 divided by 2, which we can further simplify to square root of 3, which we can further simplify to 3 divided by square root of 2. This is what we get if we plug in 1 divided by square root of 2 in the left-hand side. Now let's plug it in on the right-hand side. We have 3x, so right-hand side equals to 3 times 1 divided by square root of 2, which is equal to 3 divided by square root of 2. Since the left-hand side and the right-hand side are equal, then we can accept this answer. So this is a possible answer. Let us try the other value of x that we got. So on the left-hand side, we have square root of x squared plus 4. So negative 1 divided by square root of 2 all squared plus 4, which is equal to negative 1 squared divided by square root of 2 squared plus 4, which is equal to 1 divided by 2 plus 4, which is the same as what we got before, which is square root of 9 divided by 2, which gives us 3 divided by square root of 2. And now let's plug in this value on the right-hand side, and this gives us 3 times negative 1 divided by square root of 2, which is negative 3 divided by square root of 2. And we can notice here that the left-hand side and the right-hand side are not equal. Therefore, we do not accept this answer. And we only have one answer, which is x equals to 1 divided by square root of 2. Now we will move to our fourth example. Absolute value of 3x minus 2 is equal to 7. We already saw earlier that an absolute value is either equal to itself or to its negative. So 3x minus 2 is equal to 7, or negative 3x minus 2 is 7. Let's start with the one on the left. 3x equals to 7 plus 2. We move the 2 to the other side. So 3x equals to 9. X equals to 9 over 3. So x equals to 3. Or, on the right, negative 3x plus 2 equals to 7. We move the 2 to the other side. 7 minus 2 is 5. So x equals to 5 divided by negative 3. These are our two possible answers. Now we will move on to inequalities. Our first inequality is a linear inequality. it's quite straightforward. So we will isolate x, and then we will solve. So let's isolate x. We will leave negative 2x on one side, and we will move 5 to the other side. So we can subtract negative 5 from each side. So 5 minus 5. On the left side, we no longer have the 5, and on the right side, now we have 4. Now, we would like to divide both sides by negative 2. And when this happens, do not forget to flip the inequality sign. In other words, first of all, negative 2x divided by negative 2, we get an x. And on the right side, 4 divided by negative 2 is negative 2. But our inequality is no longer like that. It's the opposite way around. So now x is less than or equal to negative 2. Now we will move on to an example with fractions. So we can also start by putting the fractions on the same side. We want an inequality with 0 on the other side. This is our goal. So we will try to reach this goal. So we will move 1 over x plus 3 to the left side. And now we will simplify. So we want a common denominator, which in our case can be x minus 2 times x plus 3. Since I multiplied my denominator by x plus 3, I should also multiply the numerator. Same thing for the second fraction. I multiplied my denominator by x minus 2, so I should also multiply my numerator by x minus 2. These two fractions have the same denominator, so I can add up the numerators. So let's simplify the numerators. We get x squared plus 3x minus x plus 2. And now let's simplify the numerator further. So we get x squared plus 2x plus 2 divided by x minus 2 times x plus 3 is greater than 0. Now we will try to factor the numerator to see what happens. So b squared minus 4ac. B is 2, so 2 squared minus 4 times 1 times 2 is 4 minus 8, which is negative 4. It's negative, so we cannot factor it further. So what we will do now is we will draw a sign table. So in the sign table, the way to proceed with that is to write each factor you can see, write it in the sign table somewhere. So we have x squared plus 2x plus 2. In the denominator, we have x minus 2. And we have x plus 3. And then the last row is the overall fraction. So x squared plus 2x plus 2 divided by x minus 2 times x plus 3. Now, if you were wondering what to write at the top of the sign table, the answer to this is to try solving each of these factors equal to 0. Try solving it. So we will try x squared plus 2x plus 2 equals to 0. We already said we cannot factor it, so it is never 0. Now let's try x minus 2 equals to 0. We get x equals to 2. Let's try x plus 3 equals to 0. We get x equals to negative 3. And this is what we will write at the top of our sign table. And of course, negative infinity on the right and positive infinity on the, negative infinity on the left and positive infinity on the right. Now we will work with each of these factors. So the first factor, you can just try plugging any number in these intervals. You can try -5, you can try any number, and you will notice that when you plug these numbers, you will get a positive answer anywhere. So the first factor is always positive. Now the second one, x minus 2, we agreed that when x is 2, this is 0. And when x is greater than 2, so if x is 3, 3 minus 2 is 1, so we can see that it is positive. Now if x is less than 2, so if you take x is equal to 1, 1 minus 2 is -1, so it will be negative. Now let's go to x plus 3. We agreed that it is 0 when x is -3. Now if x is bigger than -3, let's say x is 1, so 1 plus 3 is 4, so it's positive. And if it's even bigger, so if x is 3, 3 plus 3 is 6, it will be positive. However, if x is less than -3, it will be negative. Now for the overall fraction, keep in mind that the denominator should not be 0. So at x is equal to 2, it does not exist. And when x is equal to -3, it does not exist. However, the overall fraction in this interval, so from -infinity to -3, just look at the signs and multiply them. Plus times positive times negative is negative, negative times negative is positive. Second interval, plus or positive times negative is negative, negative times positive is negative. Now third interval, positive times positive times positive is positive. Now let's look again at our inequality. We want it to be positive. So where in here is it positive? It's positive in this interval and in the third interval. So we will write the intervals. X belongs to -infinity, -3, union 2 till infinity. The reason I'm using open brackets is because anywhere we have infinity, it has to be here and here, it has to be open. And we already agreed that it does not exist when x is -3 and when x is 2, so I have to use open brackets. And the last thing is that the inequality is greater than 0 and not greater than or equal to 0. So now we will move on to learning about inequalities with absolute value. The first thing I want to point out is whenever we have the sign less than or equal to, we use the word and. Whenever we have greater than or equal to, we use or. So let's solve our first example in order to clarify all of these ideas. So I will show you how to solve such inequalities. When we have the absolute value of x minus 4 is less than 7, first rewrite it and rewrite it, but flip the inequality and flip the sign of 7. Solve each of these inequalities. On the left, we get x is less than 7. On the right, x is greater than -3. If we were to draw a number line, x is greater than -3 is in here, and x is less than 11 is also shaded. So our answer is x belongs to -3, 11, open brackets, because our inequality involved less than. If our inequality was less than or equal to, we would have put closed brackets. Now let's move to the second example. 3x, absolute value of 3x minus 12 is greater than or equal to 6. Again, same strategy. First rewrite it, or in this case, because we have greater than or equal to, and then we write it, we flip the sign of the inequality, and we flip the sign of 6. It becomes -6. We solve on each side. On the left side, we get 3x is greater than 18, so x is greater than 18 over 3, x is greater than or equal to 6. On the right side, we get 3x is less than or equal to 6, x is less than or equal to 6 over 3, so x is less than or equal to 2. So let's draw a number line. This is 2, this is 6, x is less than or equal to 2 is here, and x is greater than or equal to 6 is here. And we can see now why we use the word or, because we have two regions that we are looking for. So x belongs to negative infinity 2 union 6 till infinity. And I did one mistake in here. We have to put closed brackets around the 6 and around the 2. And we never put closed brackets around infinity. We always keep these open. Now the last thing I would like to show you is graphs. So if I were to graph this first one, or sketch it maybe quickly, I will get something like that. And maybe let's put the line y is 7. And we can see that we are looking for the region where it's less than 7. So we are looking for one region in here. However, in the second example, let's say this is our graph. And let's say this is the line y is equal to 6. We are looking for the regions where it is greater than 6. And this is why we get two intervals.